A ripple tank is a scientific apparatus used to study and visualize the properties of waves, particularly the behavior of water waves. It consists of a shallow container filled with water and a wave generator that creates disturbances on the water surface. The tank is often illuminated from below to make the wave patterns more visible. Ripple tanks are commonly used in physics education to demonstrate various wave properties. Here are some key properties of waves that can be explored using a ripple tank. Wave propagation. A ripple tank allows you to observe how waves propagate across the water's surface. When the wave generator creates a disturbance, such as a single pulse or continuous oscillation, waves spread outward in concentric circles or lines. Wavelength. The distance between successive wave crests, or troughs, is called the wavelength. In a ripple tank, you can measure the distance between wave crests to determine the wavelength of the water waves. Frequency. The number of complete wave cycles that pass a certain point in a given unit of time is called frequency. It is usually measured in Hz, Hz. In a ripple tank, you can vary the frequency of the wave generator to observe how it affects the wave patterns. Amplitude. The amplitude of a wave is the maximum displacement of a particle from its equilibrium position. In a ripple tank, you can adjust the intensity of the wave generator to change the amplitude of the water waves. Wave speed. The speed at which a wave travels is determined by the wavelength and frequency. In a ripple tank, you can calculate the wave speed by dividing the wavelength by the period of the wave, which is the inverse of frequency. Reflection. Ripple tanks demonstrate the law of reflection, where waves bounce off a boundary, such as the tank's edge, at an angle equal to the incident angle. This is similar to how light reflects off a mirror. Refraction. When water waves pass from one medium to another, e.g., from deep water to shallow water, they can change direction due to changes in wave speed. This is known as refraction. Ripple tanks can help illustrate this phenomenon. Interference. Interference occurs when two or more waves overlap, resulting in either constructive interference, waves reinforce each other, or destructive interference, waves cancel each other out. Ripple tanks can show interference patterns. Diffraction. Waves can bend around obstacles or spread out as they pass through openings. This behavior is known as diffraction. In a ripple tank, you can observe how waves diffract around obstacles and openings. Standing waves. By generating two waves of the same frequency and amplitude but traveling in opposite directions, you can create standing wave patterns in a ripple tank. These patterns have fixed nodes and antinodes. Using a ripple tank, students and researchers can visually explore these wave properties and better understand how waves behave in different situations. It's a valuable tool for hands-on learning and illustrating concepts related to wave physics.